an early warning system in the Hindu Kush Himalaya, and what we have done it here. So my first slide is the image of the Himalayas of the HKH region. So this is a region where we work. So it is a global asset for food, energy, water, carbon, culture, and biological diversity is there. It's quite a rich area. So this HKH region where we work is has 10 major Asian river systems like Amudarya, Tarim, Yellow River, Ganges, Mekong, Salween, Ganges, and Indus. So we have 8 countries here, similarly from Afghanistan to Myanmar, which also include China, India, Pakistan, Bhutan, and Bangladesh. So within our region, there are about 210 million people living in the HKH region. So which have to use the water in the various forms. So there are 1.5 billion people in the downstream. So my current focus will be on some of the activities we have done in the survey. So survey is a joint initiative of USAID and NASA. So ICIMOD has been involved in this for the last maybe near about 10 years now. So this survey is expanded in the all 3 different continents, like we are in South America, Africa, and Asia. And in Asia, we are HKH Survey Hub, located in Kathmandu, and work within the survey with the different countries. Okay. So this in survey, we mainly focus on the satellite-based or the model information system. We use various satellites for aqua and terra for snow, Landsat for land use, land cover, and various others like chirps and this thing for rainfall, which we'll be talking a bit more about. So we have a clear picture that the in situ observation is always better than the satellite images, but looking at the remoteness of our places, so the having this physical station is not that feasible in all the places. So it is quite expensive, especially on the highly mountain areas where we have to carry them, set up them, and of course also there is cases of vandalism of the instrument. So we need to have a constant repair kind of thing. So in the survey, we have taken mainly a satellite-based or a model-based image and data set on which we try to model and give information to the users on the floods and other things too. So this is a flood scenario in Nepal in the last few years. The first one is of the Nepal, which is on the very near to the Kathmandu area. So there was a big rainfall on the monsoon, and which brought a huge water flow near the Kathmandu, which also put a lot of people in the risk. So flood is one of the most occurring and costly natural disaster in the HKH region. So the second big flooded country is Bangladesh, where we have a flood in every monsoon, and this also losses in the properties and these things. Third is Bhutan, and so on. So we have quite the HKH is a quite prone area on the flood. So this is also one of the major break of the pool. This happened this year only in July. So there was a heavy monsoon which broke the bridge, and a lot of people has a problem in having this crossing the bridge. And this is also the COVID time, so the people face a lot of problem. The rescue people also had difficulties in serving the people at other end. So the flood is a very prone thing. And the same thing is shown on one of the studies, which the ICIMOD has published a paper or a book kind of thing in the Hindu Kush Himalaya assessment. This shows that the flood is a major contributor on the disaster side of the region. So 40% of the events that happen in the HKH is flood or flood-related events, and economic loss by the flood, so that is a 52%. Though we have other kind of disasters too, like we have an earthquake which hit Kathmandu, which hit Nepal in 2015. We have a droughts. We also are working on a droughts too. We have extreme temperature, like a change in temperature, the lightnings and these things. We have an app, and if we have a time, then we will also have a little look at them. And these are the disasters which are mainly done by the flood or the river basins in the whole HKH region. So this is also the study paper is there on the same book. So I have put a screen capture of this one here. So this is how the water related disaster is hampering the region and affecting the people. So how the flood occurs in this mountain area is that, number one, the mountain area, the climate change plays a vital role. The range of the temperature melts glaciers or the snow quite faster than the normal ratio. The second is a topography. So we have a very tough terrains kind of things. So the water flows from there. And also the third part is infrastructure. The people housing and this thing and this part of the globe is very near to the river, maybe for the agriculture purpose or for the livelihood purpose. They like to have their living near the water areas. And of course, they sometimes encroach the river when the river is not in their full length. So the people try to encroach the river, and when the flood comes, then the people get affected a lot. So the lesson from the past, what we see in this HKH region is that we don't have a continuous or data gaps within the region, and we don't get enough lead time. Like if we have a station, we will maximum get 2 to 3 hours or few hours of lead time, but not much than that. Of course, there is no information also is there. So if even if there is information, then the transfer of information is also quite difficult on this area. And since this area, the HKH has 8 countries, so the capacity of this thing is varies from country to country. Like some countries like India and China are quite advanced within their system, and other countries like Nepal, Bhutan are quite weaker. So the capacity of dealing with the flood is also quite different in these different countries. And of course, we also look at how does the transboundary cooperation can help reduce the flood and its mitigation measures. So here, as I said, I'll be focusing mostly on the survey application, though we have a few other technologies which uses the flood. So in survey, we have major 2 tools, which is called ECMWF stream flow prediction. This is a prediction developed by the ECMWF, and we have remodeled it by the Muskingum algorithm and make it river-wise. And secondly, we have a high water rapid flash flood forecasting system. So this second one is mainly used for a flash flood, where the flood mainly occurs due to the heavy rain. So this is also joint developed by the NASA team. So let me focus on ECMWF. So this is a co-development by the BYU, the Brigham Young University, and NASA. And the workflow of this one is quite simple. So we have ECMWF or a GloFAS forecast, which is on a gridded format. Okay. Then we run on the watershed model there. Then we calculate the watershed areas, small areas, and the flow direction. After that, we generate the weight tables. Then we get then we run a rapid process. From the rapid, we convert this gridded information to a river network. Okay. Then once we have this kind of information, then with the use of the Python, we put them to a database. We have historical return periods and forecast for a river network. Once we have this kind of system here, then we disseminate this information from the various web platform, like some may be the country-wise, some may be the special request by the country. So they want to see or they want to focus on specific areas. And we also have developed the API system for this so that a lot of people can use the database directly without going through these other processes. So ECMWF is quite straightforward. It is available year around. So it is updated daily, and it will give you 10 to 15 day of forecast. Okay, and the forecast variable is the river flow, and it uses ECMWF and Rapid to organize it. And it has 52 ensemble members, like 51 are developed from the 16 kilometers, and the last 52 ensemble member is 8 kilometer high resolution. And the high resolution one gives a forecast for 10 days, and rest one is for 15 days. And we also have ERA interim data set for historical scenarios. We have decades of historical data set to show how that river particularly behaved there. And this is one of the example what we have developed is a regional based flood prediction system. So here we have tried to capture almost all the area of the HKH region where we work. So this is a very big network of the rivers. This is shown by the colors, like if the forecast will be severe, then that will be like a 20 years return period forecast, 10 years, 2 years, and the blue one is normal. So this is shown by the color of the river. This has been calculated from the ECMWF. And this whole model is run at ICIMOD's center. So once they know the condition of the river, actually this one is showing more greener because I just made a screen capture a few days back where we have finished the monsoon season. So there are only few regions where there is showing red areas. Otherwise, this whole area on the Nepal belt, this like Nepal, Pakistan, Bhutan, this all shows in a very colorful kind of thing. It shows yellow, orange, and this kind of thing. So now the monsoon has passed, so it is showing almost all the blue. But we have some areas where it is still showing there will be a high discharge of water. So once we click on a particular river segment which we want to see, then this will show you how the river will behave on the particular time frame. So it is 15 days or 10 days for a high resolution. So on each one, if you slide it, then you can see at the particular time what will be the flow. And since we say that this is also the ensemble members are there, 52. So this is also percentage of the probability calculated from each ensemble. So this is about probability calculated from ensemble parameters. So if even there is a river showing that it will be showing maybe 2 years return period, the percentage from the ensemble shows that it is only a 4% chances are there. Similarly, these are days why it can show. And of course, you can download the particular data sets, the first historical data set from this website. So once we made this a regional one, so there was a lot of demand from the country level. So there was a demand from Bangladesh, Bhutan, and of course Nepal. So we also have developed a similar structure for Bangladesh. We have this similar thing for other countries too. So for this example, I have taken a Bangladesh here. So this is a major rivers of the Bangladesh. So this is showing the probability of the water discharge by the rivers. Of course, then the same thing is there, so it will show you the chart showing how the water will behave. Of course, the probability of this particular day. Then we have a historical data set, the decade-long historical. In past, when we were developing a data set, we have only till 2015, but now our team have expanded it to 2018, but still we need to cooperate in this portal, but we have a historical data set for each river segment till 2018 now, but is not integrated in the portal yet. And of course, you can also see the flow duration curve for that particular river segment. And of course, then again, a download portion, you can always do a download and browse through the data set on your own convenience, or you can remodel from this download data set on your own methodologies. Now, once we get this kind of thing, we also get some requests like this is a special request done by the Bangladesh FFWC. This is one of the government organization. So Bangladesh is one of the highest flooded area in the HKH region. So they want to know on the transboundary areas, how much the river will discharge the water from that particular river, because the data sharing mechanism on this HKH region, the transboundary data sharing mechanism is quite weak at this point. So this side, if you see the bound, this side is India and this side is Bangladesh. So they have the good model running here, but they are not sure that how much data they can forecast or how much flow will be there in the 10 or 15 days. So they don't have this kind of information. So they have requested to make this kind of application on the mainly focusing on the boundary areas where they have the stations. So once we give them a data set by the API, here we have used the API to transfer the data set for this particular requested point. So this data set is again integrated on their models, and they will have a much better forecast time on the inside the country. So they can do their forecast timing will be much better than the previous one. Previously, they used to have the forecast for few hours, but now with our system, they are doing forecast much better for days, few days or weeks kind of thing. So they can do a good forecasting inside. So this is a client request for ICIMOD, and which we have solved them. The second one, what we have is a high watt flood prediction system. So this is also a joint developed by NASA, and this whole model is so big that it is still running on a NASA security system. So we are trying to import this model to ICIMOD, but the model is quite bigger, and we don't have a big infrastructure here, so it is still there, and we take the data from there. So this high watt focus system was mainly designed for the extreme climates. So it does a 54-hour forecasting for the various of the environment parameters like hailstorm, lightning, rainfall, and other things are there. So this also has been implemented through the Surveyor, and the data generation of this one, which of course runs on the NASA yet, has an input from the NICEP and spots, which goes to UEMS model, and it generates 12 ensembles. Here we can see each of them. And of course, once this ensemble are generated, then for the final output, they combine these ensembles and make a particular one image or one data set, which we can see on the particular map here. So this one is particularly in a higher resolution. Maybe I have next slide here. So high watt is a small system in compared to ECMWF. So for the 12-kilometer run, it runs in the HKH region, but this has less parameters. But we have a high resolution one, 4 kilometers, which is mainly focusing on the major forecast areas like for Nepal, Bhutan, and Bangladesh. These countries are mainly focused in the 4-kilometer area. So it gives us a 54-hour forecast. And it has this parameters. So these parameters are varying. There are some physical conditions, and the initial conditions are set here. And these things runs and gives us the output in the 12 ensembles. So these are 12 ensembles we get from these changing of these physical and initial parameters. So these are an ensemble of each of the run, so which we combine this into a probabilistic forecasting, and we get the result, this one, and this result is used to analyze this further. Okay, so this is a website which for each application we have a respective website where the users can view it. So this is a high watt extreme climate portal, so where you can view all the final data sets on the website. But I think I forgot to mention one thing here. So this high watt system, looking at these resources and consumption and these things, so it is only run on during the monsoon period. So this high watt system runs from March to the end of September. So these are very high peak areas where the flood will be quite big in this region. So we also call this a monsoon region. So this runs till September. So now it has stopped running it, and it is still showing the old database, not the current one. So this is also available, and if the time permits, then I can give you a small demo on this one too. So this is a high watt system, and within this high watt, taking the precipitation, then we have generated the high watt flash flood forecasting system. So this is a high watt is 48 or 54-hour forecasting system, mainly focusing on flash flood. That means that the only input parameter it takes is precipitation. Like if there's a heavy precipitation, then the coming of the flash flood is much more than the other parameters. So for this high watt, precipitation or the rainfall is the major contributor. Okay. So this has a very wide area of network of the rivers, and it also covers the small river segments where it shows the chances of the water flow. Of course, this has been used by the government of Nepal, Bhutan, and the Bangladesh, and they have contributed in a lot of other parameters. Like we can see the detail of the E segments with the color coding. The color coding is same as in ECMWF. Of course, they also want to know the river names, and this is given by the government of Nepal. So they are quite interested on this kind of things, because the flash flood is also the quite occurring thing in Nepal, and Nepal government doesn't have a good system for the flash flood. They have the major systems on the major rivers. They have a lot of stations, but for the flash flood, so they are using our system as one of the decision-making tools. So here also we have decadal-long historical data sets and flood conditions, which is shown here. Third, what we have is a built is API system for all these two systems. So there are a lot of the other partners, smaller partners. They have the particular area of interest in Nepal, like they have a small area where they work, and they only want to do the forecasting of the particular small areas on their portal. So upon their request, we have developed an API system. So from the API system, they can request the data of their particular areas and display on their own system there. So this API system has been launched for them, and of course this can be used by others too. The API system majorly requires this token. So once you register to our system, then it will generate a token here, and so and if you have a token, then you can use this thing. And this is a page for API Information Center. So if somebody wants to use the API, then it will give you a guidance that how you can use the parameters to request the data. So you can have a data for a forecast, for the historical data set, for the return periods. This kind of data can be downloaded from our system. And the other big component which is undergoing is a validation of the data sets. So validation is a quite important part, and a lot of our government partners are cooperating with us to do a validation. So for the validation, we have an inbuilt tool called a hydrostat. The hydrostat is a Python-based tool which has been launched at the ICIMOD portal there. So where you can compare the data sets from the forecast output plus from the stations, and compare what are the differences, are how good is the data from our forecast. So these are the tests where we can do it. So we can compare the data from observe and also from the prediction data sets and compare it in a wave format. So this is a tool where you can upload your observation data sets. And you can see once you have download this tool, automatically gives you, if there's any data gaps, it shows you that this kind of gaps are there. And these tools also have a possibility that if you want to fill those data gaps with interpolation, then you can also fill them. If you have a small gap, then you can of course fill them. Otherwise, you can leave like this one. And it gives you a comparison, like you can merge the observed data set with the forecast data set and see the differences. And these are all through the website. You don't need any other software kind of things. And also you can do a scatter plot kind of things on your forecast data sets and have the error metrics, like a root mean square error or what kind of error you want to do it. So there are a lot of parameters which we have given on the website where you can select there. So for me, I have chosen 5 of them for this demonstration, and you can see what is the what kind of error are there on your forecast. So in our case, we have done forecast for these stations in Nepal and Bangladesh, and we found on the deterministic forecast that the forecast time and the forecast values are a bit changing. So instead of going the actual forecast values at ICIMOD, we are thought to do a categorical forecasting. Like the categorical forecasting means that if our forecast system has indicated that the river flow will be higher, then did it happen on the real scenario too? So this kind of things we are observing. So here, this is a table here, we have a chart. So we have observed, we have hit. Hit means that uh, event forecast to occur and did occur. So that it shows that if our system has said that the river flow will be high, and it did happen higher on the observation side too. So this is a good point. Missed means that we said it will be higher, but it didn't. And the false alarm is that even sorry, missed was something I said. The false alarm was that one. Like we said that there will be the chances of the flood is there, but it didn't happen. Means there's a false alarm. Missed means that we didn't forecast it, but it happened. And the correct negative is that event forecast not to occur and also didn't occur. Like we said, there will be no flood and it didn't occur any flood. So this kind of validation method we have implemented, and on the conclusion, but after analyzing this part, we found out that our forecasting method is a bit higher in the tool is overcasting in some of the rivers, like mainly in the high mountain areas. It is doing more forecasting or over forecasting there. So the tool has a skill score greater than 1, indicating the forecast had good skill in capturing the high floods. Like if there is some high flood forecast is there, then our system is good in capturing this high flood forecast, though it does a little bit of this over forecasting. Of course, in the ECMWF, we have a 15-day of forecasting. So the forecasts are good in the earlier periods, like maybe for 4 or 5 days, forecast is good. But as long as the time period expands, then the forecast score also get decreased. So that is how we conclude our validation session on our data sets. So third, we have also have this success story. So this system, what the forecast system has been quite popular in the governments. Like this is a government website which they have used one of our system to forecast the areas and alert the people. So this is quite a good part for us, and they are also helping on validation part with us. This is one of the teachers on the remote village for whom we have given a training kind of thing. So we have given capacity building training for them. So they took a training from us, and they went back to the village, and they were monitoring the website, and they were quite good in forecasting that, okay, if our website shows the forecast shows that the river flow will be higher, then in the most of the cases they found that the river did become higher, and also by this they could also save some of the peoples and houses using our forecast. So that is what they have reported, and they have also put a video onto it. In the other side, our forecast has also been used by the various other tools. Let me go back. Tools. So this is one of the practical action group in Nepal. So they are working on a smaller area. So they have implemented our forecast, and already is a government website, which is a BIPAD. So they are also using the ECMWF forecast from ICIMOD to report on their disaster portals. So what we have at ICIMOD is that for the development of these applications, we have used a platform called a Tethys platform, which is open source platform. And why we have used this open source platform is that in the upcoming years, like 2021, a lot of our partners want to implement this system on their own organizations, like on their own servers. In this way, the open source platform becomes quite handy for them. So they can, so we can easily implement this system on their own servers, and after that, then they can use the data and all information at their own end. So the open source platform is there. Uh, and of course, this data is also freely available from our website, as we have the ICIMOD mandate on the data sharing policy, which states that every data that has been generated by ICIMOD should come in a public domain. So considering that data sharing policy, we have put all of this data set in a public domain on this URL. The user can have look at this, sorry, it's going quite URL and download the data set as they require. And if the time permits, I think I have time, so I can give a demo of this application and how the data can be downloaded from the website. And I have a last slide here on the regional database system. Beside this time series data set, we have at ICIMOD, we have called a regional database system. This system is used to download the data set. So we have a lot of data set here, like not only a flood, we have glaciers, we have a snow and everything. So this data set uses a ISO standard metadata system to browse the data sets. So the user can use the system, they can browse the data sets, they can search what the data they are looking for, and if available, then they can download it from our end. So with this one, I'll like to go for a demo of some of the systems, what we have built. So do I have time now or? Okay, I think I have a little bit of time, so I'll go to the first one. Can you see my new screen now? I think for the application part. No.
Hello, doctor.
Yeah, I want to change the.
Yeah, you have time. You have time.
Okay, let me go some of the demo.
Okay.
In slideshow. Okay, then I'll go to some of the demo what we have. Can you see my new screen now with the website? Hello?
Yes, I can see the map.
Okay. Yeah. Okay. This is one of the application for high water system which we developed for the Bangladesh, which I have shown in a presentation too. So this is a live data set. What we have, and these are the Bangladesh boundaries, and this is shows the flash flood. So these are color codes here. Now you can click on any of these areas. So it will show you the forecast for a particular time. This is high water, so it has a 54-hour forecasting system. So each time period you can see, and maybe in this particular time area, like it is on the October 4th, there might be the river might be higher. So it is showing you that one. And of course, there is also the historical data sets which you can download for a particular river segment. So we have from 1980 to 1915 till now, but we will be soon expanding to 1980 to 2015. So we'll be expanding till to 2018. And of course, this data set is available for the downloads. And we have other system here, this ECMWF system, which does a 15-day forecast. And this is a huge network of the rivers, so it sometimes becomes slower looking at the bandwidth. So this covers all the major rivers of our HKH region. And if you want to see any of the segments and how the forecast will be for next 10 to 15 days, then you can click on a particular section of the river and have a forecast for next 10 days. Here. And this is also the percentage or the probability which has been calculated within the time, within the 52 ensemble members. So what will be this? So this at 1st of November, I think. Yeah, there is a 10% chance that this retriever will have a return period to forecast there. And of course, same thing can do a download. The third one, which I want to highlight a little bit, is mainly on. Okay, close it. Okay, so this is a high water system. As I've said, that this high water system has stopped running because it only runs on the monsoon time. So I have put some backdate data set at a 7.9, and I will show you how this high water system works. So it has ensemble hourly forecast, and there are the parameters here. So if you want to go in accumulation of the rainfall, it shows this one, and this is for a 7.9 at the 16th hour, sorry, at 18th hour. So you can also see how this precipitation changes according to the time. It's taking a bit slower time to load. It depends on the internet, but you can see how this total accumulation of the precipitation is changing within the 54 hours. Of course, if I pause this, you can also do the similar things on the lightning part, like probability of lightning on this area. Lightning also is one of the for disaster which kills quite a number of people and destroys property in the region. So this is a probability for lightning on this particular area. Okay, and similarly we have this what you call hailstorm forecasting. So hailstorm seems quite less on this part of the area for the particular day. And then the wind speed is also there. So it has most of the parameters require to do a disaster analysis. Let me go back to the hourly ensemble. This has more. And this is a 12 kilometers resolution one, which it covers a bit bigger area, but this has a bit less parameters than what we have on the 4 kilometer ones. And of course, if you click on this anything, and if you want to do have some statistical analysis on a particular area of interest, one can draw a polygon and have a chart or the analyzed chart of that particular area here. And as I said, this whole data set is on a downloadable format. So this is a website from where you can download, like I just showed you a high watt one. This is a high watt. There's all the daily data sets is available. So somebody can click here and download it. data set as and when required. So thank you. That's my time, I think. So if you have any questions, then I'm there.
Thank you very much, Professor. Thank you for your excellent question. Hello, everyone. Is there any questions? I will